Observing the transit of Venus really means observing the Sun. Here you can see the approximate times and positions of Venus in relation to the Sun. You'll be able to see the transit of Venus from anywhere in Europe, but the time will depend on where you live. This is what gave scientists the idea of linking students and the general public across the continent in one project. The European Southern Observatory, the Observatoire de Paris, the European Association for Astronomy Education and the Czech Institute of Astronomy of the Academy of Sciences announced a joint project, Venus Transit 2004. I'd like to emphasize that this is not a project aimed at new discoveries and new scientific results. What we want above all is for the broader public, amateur astronomers and especially school children to try out scientific methods and scientific measurements so that a very important experiment can be repeated. Grammar school pupils in the town of Prostějov, led by their physics teacher, will try to surpass astronomers of earlier centuries. We registered on the vt2004.org website. If you click on the link How to Participate, you'll find the next link, Registration, and then you just follow the registration procedure, filling in the required data. You have to fill in the country where you live, and most important of all, the latitude and longitude of the town where you are. Participants can either find this on local large-scale maps or use the GPS receiver. In this age of developed technologies, possibly the most elegant method. In this case, school pupils found their geographical position by using the internet. Latitude is 49 degrees, 22 minutes, 21 seconds north, and the longitude 17 degrees, 6 minutes and 56 seconds east. You can use many different ways to observe the Venus transit, from the simplest to the most complicated. One possibility, I'd say a poetic one, is to go to a park, find a leafy one with lots of foliage on the trees, and look down on the ground, where you'll see how the light shines through the crevices between the leaves, creating something like little suns with diameters of about 10 centimeters. Another reasonably simple method is to use a mirror. As the sun moves, direct the mirror towards the sun and let it project onto a wall which is in the shade. That way you'll get an image of the sun, which you can look at to observe this phenomenon. The grammar school also works in close cooperation with the observatory in Prostějov. The general public can learn about a variety of methods of observation as well. You can buy tested glasses at observatories in the Czech Republic. The glasses you see now have been issued with a certificate. It's safe to wear the glasses even for longer periods, and the Venus transit will last all afternoon. Someone who does not plan to visit an observatory can buy a welder's filter. Glass with a filter factor of 13 to 14 is the most suitable. Some institutions may even buy this Venus scope. It's based on the traditional camera obscura principle, but is fitted with optics and a mirror which reflects the image of the sun on the screen. Everything that happens can be seen perfectly. These sunspots, for example. The pupils of the grammar school in Prostějov have another observation instrument, designed by their physics teacher, Mr. Halash, and made by their skillful school caretaker. You will need mainly binoculars, a tripod, a rod and some pads. Now we'll fix it so it holds tight. And now I'm adjusting the rod so it's parallel with the binoculars.
Teď urovnávám tyčku, aby to bylo trošku rovnoběžně s tím dalekohledem. Srovnáme, zakryjeme jedno.
If we want to determine the exact times of contact between the Sun and Venus, we'll have to set a watch according to the radio or TV time signal. There's also a time signal transmitter in Frankfurt am Main. The transmitter signal is received all over Europe, and some watches are regulated automatically according to this signal. We find universal time by deducting 2 hours from Czech summer time. Then all that remains is to watch for the exact moment of contact. The European Southern Observatory has offered a prize for the best video recorded in connection with the Venus transit. The winner will visit the La Silla Observatory in Chile. I study at the Technical University, but I'm not really a scientist at all. I just make use of technology to express and communicate what I feel. Monica is participating in the competition. Her work is conceived in a very unusual way. I'm making a video about Venus in such a way that the main role is played by the story, the action. So I'm trying to shape and depict Venus as a woman and man together. Students from the grammar school in Prostějov have entered a competition set by the British Council in the Czech Republic for the best website in English. It should be something in the style of the universe. There should be some planets, some animation. Then we'll see how it goes.
The competition is open to all schools in the country, and we've already had a lot of expressions of interest for it. The school which wins, the website which wins, we'll be inviting the young scientists to put it together to the London International Networking for Young Scientists.
Another method of observing the Venus transit across the Sun will suit owners of really high-quality astronomical telescopes, for which some companies supply professional filters. These filters transmit approximately 0.1% of impact rays and cut out infrared and ultraviolet rays. An instrument like this allows you to make digital photographs or a video recording. On June the 8th, we will see a picture similar to the one we saw during last year's Mercury transit. However, Venus will be much bigger. Even so, it will only just be visible with the naked eye. Different temperatures and stratification of the air may cause turbulence in the Earth's atmosphere. In these cases, the quality of the photographs is very poor. So there are methods that enable us to reconstruct such photographs of a sunspot, or, in our case, the little Venus disk, in a mathematical way, using special computer programs. People with an interest in this may send a low-quality digital picture to the internet address of the observatory in Ondřejov. The pictures will be processed automatically and the improved version returned. With this telescope we go back to the projection method, but using a reliable telescope which enables us to project an image of the Sun onto the screen with a diameter of 1/4 meter. However, it will be difficult to set the time of the first contact between Venus and the Sun. Hardly anyone will be able to measure T1. Other contact times should be measurable by almost anybody. School pupils and the general public can then send the times measured via the internet to the headquarters of the European Southern Observatory in Garching, near Munich. So everybody will be able to find out how to measure the exact distance between the Earth and the Sun. But do be careful. You must protect your sight during observation. Sunglasses, undeveloped film and floppy disks are not enough. Only special glasses and filters are suitable for observation, as these eliminate the part of the electromagnetic spectrum with malignant effects. Infrared rays can cook the retina, whilst ultraviolet rays cause irreversible chemical changes to the outer layers of the eye. But what happens if it's overcast or rainy on the day of the transit? There's a dense network of observatories, planetariums and museums in the Czech Republic that have prepared substitute programs. It will be possible to watch the Venus transit thanks to internet relays from observatories that will have a cloudless sky above them.